How are you?
I'm good. So how are you? So your exam will happen on Sunday, right?
Yes, sir.
And how is the preparation going on? So Aisha has provided you some question paper, and I have also sent you a question paper of Tarif. So one of my student, and he has also sent me those. So please look
Yes,
at,
sir, I will.
yeah, please look at those papers, see the pattern, and practice those. Okay. So earlier, Aisha told us that her exam was so derivation oriented. So there were lots of derivations. So first prepare those derivations and then yeah, do something like this. Okay.
Yes, sir.
Okay. So now we are starting this second book, and I will also what I will do is that at some point later I will start this revision of this first book also. So we will simultaneously complete the first book and then also this second, right? So in first book, who got disconnected? My Mariam got disconnected. Okay, so what should I- Okay, so where is my why she got? Okay, so let me give a quick recap, just a glance of what we have studied so far, right? So in the first book, what did we learn? So in the first book, now it will be. So in the first book, we had first was electrostats, right? And then we understood about electric currents, and then we talked about magnetostats or magnetics. And after that, we did EMI, electromagnetic induction. Then we understood about AC, and then we understood about this EM waves, right? So these are the chapters that. So in the electrostats, we talked about uh, electric charges and fields, right? And in the second part, we talked about electric potential. And in the electric current, we talked about electric and magnetics. So in electric current, we talked about moving charges, right? And we also talked about magnetics. One moment, one minute. Yeah, sorry about that, guys. So Yeah, and in the magnetism, we talked about, so this part I have to provide some notes. So we talked about properties of earth magnet, right? So this part, I have to send you guys some notes. And so earth magnets and types of magnetic material, right? In the EMI, we talked about Faraday's law, and then we talked about this AC generator. And in AC, we talked about mainly LCR circuits, and then we talked about transformers. Right, and in EM waves, we talked about Maxwell equations, and we talked about EM waves, spectrum of electromagnetic waves. Right. Okay. Again, did she get again? Did she got disconnected? Right. So in electric charges and fields, in electric charges and fields, we talked about charge. Right. What are the properties of the charge? All the things associated with the charge. And then we talked about this Coulomb's law. Right. So we talked about Coulomb's law. And then we also talked about vectors and their application. After that, we talked about electric field, right? And then superposition principle we talked about. And then we calculated electric field of different kinds of distribution. After that, we also talked about the electric field lines and then electric flux. And then we also talked about the force on charged particle in external electric field. In the presence of electric field, we talked about the torque experienced by the dipoles, right? So we talked about this dipoles also, electric field of dipole at the equatorial. So at the equatorial point and at the axial point, right? So these are the things that we, and then in the last we talked about Gauss law. So these are the things we did in the first chapter, right? And in the second chapter, we talked about electric potential. We talked about electric potential. First was work done in the presence of electric field, right? In the presence of electric field, then we talked about what is potential, electric potential, and then we talked about what is the relation between potential, electric field as gradient of potential. Then we calculated the electric potential of different kinds of distribution, be it point charge, right? And then we talked about this dipole, right? So electric potential of different kinds of distribution. Then we talked about these capacitors. and capacitance. And in lastly, we talked about the electrostatic potential energy, right? So electric potential energy. So all these portion I will revise, right? So you, Aisha, you said that you have difficulty in this chapter, right?
Sir.
Walaikum salam, walaikum salam. So we have just started, and I'm just recapping what we have done earlier, right?
Yes, sir.
So yeah, and yeah. So Aisha, you have some difficulty in this chapter, right?
Yes.
Yeah. So we will revise all these portions, right? Again, then it will be. So then we will memorize this, and we would be able to understand it more properly. So in the third chapter, in the electric current, what did we do? So electric current, first we talked about this drift velocity. Then we understood about what is this current flow of charge, right? And remember, now we have studied this electromagnetic waves, right? So we can say that this was the conduction current. So we talked about conduction current, then we talked about Ohm's law, and then we saw the relation between drift velocity and current, and then we also talked about microscopic form of Ohm's law, current density, right? And then we talked about then we talked about the combination of we talked about resistance, right? Resistance. We talked about resistivity. We talked about mobility, conductance, conductivity. All these things we did, right? And then we talked about this. So after that, we talked about temperature dependence of resistance, and then we talked about the combination of resistances, and then we talked about this EMF of cell, and then their combination, and then we talked about Kirchhoff law, junction rule, and so one was junction rule, and then the other one was this voltage or loop rule, you can say. And lastly, we did this Wheatstone, right? So this was done in the third chapter, and then after that, okay, so Arsalan is here, right? So what should we do that?
Yes, sir.
So let us start this new chapter, and then at some point later I will revise all these portions. But for Arsalan, I will take all these chapters in there, right? So Aisha, I will discuss with you that at what time would be comfortable. So I will discuss about the timing, and then we can revise all these chapters, right, Aisha? Yeah, so let us stop it here. And now the next chapter is this optics. So I'm skipping the fourth chapter, right? Fourth chapter in magnetism, what did we do, right? And then fifth chapter, so earth magnet. And then this was this AC, and before that AC, this was EMI, and then AC, and then EMS. So all these things we have done so far, right? And it would be very good to revise all these chapters again and again, right? the initial 4 chapters are very important. For the exam point of view, initial 4 chapters are very important because they contain the maximum number of marks. So I will focus on all those 4 chapters. At some point or later, I will revise those chapters, right? But for Arsalan, I will in the yeah. So for Arsalan, I will start from the beginning, right? Your class. Okay, Arsalan.
Yes, sir.
Where is she got, okay, so in optics, what do we learn? So there are two parts of optics. One is this wave optics, right? And then this is the ray optics that we are going to. So in ray optics, what do we learn? Yeah, so in ray optics, we learn about reflection. We talk about refraction. And the third thing that we do is dispersion, right? And fourth one that we will do is optical instruments. So these 4 things we will do in this ray optics, right? And in the wave optics, what do we learn? So in wave optics, we learn about this Huygens principle. Huygens principle mainly talks about the wave nature of the light, right? So Huygens principle, and then we talked about diffraction, and then we talked about interference. So these will be the things that we will learn in this wave optics, right? So as so we should start with this ray optics, right? So what first thing that comes into our mind is what is this light, right? So as we understood in the 8th chapter, in the 8th chapter we had this electromagnetic spectrum, right? And in the electromagnetic spectrum, all these there were all these variations of the wavelengths, right? Wave nature of the electromagnetic fields, right? And we saw that there was this range of wavelength. There was this range of wavelength which was visible with our naked eye, right? So that kind of electromagnetic wave we can see with our own eyes, right? And what was the range of the wavelength, Aisha? Do you remember? So this was called the visible waves, right? So what was the range of this visible rays? Do you remember, Aisha?
400 nanometers.
Yeah, so the range was 400 nanometers, right? You can see that what is the wavelength? It's in nanometers. So this is small. This is small wavelength is of this visible wave. So 400 nanometer, absolutely right. 750 nanometers. So this is the range of. Okay, mean is also joined. Yes, Amir, assalamu alaikum. So we have just started, right? So we have started this second. So in one
Welcome, sir.
yeah, so in one portion I will do this second book, and in the other portion I will do this first book. So you have this AC and ray optics in your exam, right? Right, Meet. So you have this in your exam. What are the chapters? AC and ray optics, right?
Yeah.
Okay. So yeah, so I've just started this ray optics. So I was talking about that. What is this light, right? So we in the eighth chapter we studied about this electromagnetic waves, and that those electromagnetic waves had some spectra. So for the case of light rays, we are talking about that electromagnetic wave which comes under the visible range. So the electromagnetic wave that comes under this 400 nanometer to 750 nanometer. So those electromagnetic waves are called light, right? So the electromagnetic waves which we can see from our naked eyes, right? And the wavelength of light ranges from 400 nanometer to 750 nanometer, right? So as you guys have learned about this VIP geo, right? So what would be violet and what would be red? Which color of light will have higher wavelength and which color of light will have? My voice is cracking. Is my voice cracking, everyone?
A bit, sir.
It's cracking. Why is it cracking? Because my network is stable. So can you guys hear me now properly?
Yes, sir.
Yeah. So I was asking that what would be, so the color bands are violet to red. So this is the color band of visible rays, right? So I am asking that this ranges from 400 nanometer to 750 nanometer. So
Okay, sir.
which wavelength would be red and which wavelength would be, yeah, violet.
Violet would be 400, right?
Yeah, absolutely good. So Aisha has also told us. So this would be violet because violet has a lower wavelength, right? And that dispersed a lot, so that has a larger deviation. So when we talk about this prism, so then we can split these light rays into different color bands, right? So then we can talk about these bands. Yeah, but you guys are obviously right, of course. So this is red, which has a greater wavelength, right? And as because whatever the object that we see in our daily life, so those are in the centimeter, meters, and in those range, right? So as compared to those objects, the light's wavelength are smaller, very smaller, or larger. Yes, guys. So as compared to our daily life objects, just like those tables, chairs, and whatever those objects are. So for the case of those objects, when we compare those objects and when we compare this light rays, so is the light rays or what is the range of this light range? Is the wavelength of light range is very smaller than these objects that we see in our daily life? Or the wavelengths of these light rays are very larger than the objects that we see in our daily life, right? So as compared to the daily objects that we see, uh, what is the wavelength of these light rays? Smaller or larger? Did you guys understand the question?
Can you repeat it? I didn't
Yeah.
understand.
So we have, let's say these are the daily object life objects that we have. So let's say this is table. Let's say this is a charger that we have. Oh, I forgot about my tea. Okay, so we have this teacup, right? So these are the daily objects that we see in our daily life. And then we
Oh,
see
yes, sir.
the light rays. So these objects are in a few centimeters, or maybe let's say in we see the building, so they are in meters. So these are the ranges of the objects that we see in our daily life, right? And then there is
Mm.
this light rays. So what is the range of these light rays? What is the wavelength?
So the wavelength of these light rays, so like
Sorry, what is it?
600.
Yeah, so these are in nanometers, right? Which means that 10 to the power 9 meters, right? Is this
Yes.
so you see that as compared to these objects, the wavelength of light is very small, right? Because
Mhm.
you can ask that when we see the light, so we see that light is traveling like this way. So is this a wave? When we see, let's say somebody is in here and some source of light, let's say this is the torch, right? Or let's say some laser, so somebody pointing out some laser and this one is observing that laser. So he will directly see this laser. So light is directly or moving in a straight line, right? But how does the
Mhm.
wave propagate? Wave propagates like this, right?
Yes, sir.
So we should see the light going like this way, right? So we should see the light fluctuating, right? But we see a
Mhm.
constant light. Why? Because our naked eye is adjusted to these wavelengths, right? These centimeter and meter scale, right? So when we see these lights, so the wavelengths are pretty small that we see those lights in rectilinear propagation, right? So light moves in a straight line path. Why? Because the wavelengths are very small to comprehend with our naked eyes. Is this part clear?
Yes, sir.
So the second idea is that light propagates in the rectilinear motion. Right. So when we'll draw all these ray diagrams, we'll not draw like this, right? We'll draw the light propagating like this, following a straight line. Is this part clear?
Yes, sir.
Okay, so this was about the electromagnetic spectrum and the light and light propagation. So the next topic is so what kind of there are the objects and what are the images that we see, right? So there are two kinds of thing for light. One is this object from where the light is emitting, right? And then there would be this image. So where those two light rays, so light rays are meeting, right? So we'll talk about what are the objects and what are the images. So let's say we have this point and the light is emitting from this point. So this would be called an object. And let's say we have this point where the light is incoming. So that would be called the image, right? So there are two kinds of thing for the case of light, and one is object and the other one is image. Okay. So, but there are two kinds of objects, right? One would be the real object, right? And the other would be this virtual object. So, this real object is when the two light rays are diverging or emitting from the point, right? So then those would be called the real object. And for this virtual object, when the two light rays are appearing to be diverging or emitting from a point. So that would be called a virtual object. So let's say for this case, we have this point and these two lights are emitting from this point, right? So what is this a real or virtual object? What kind of object is this? Yes, right.
Real.
Real object. So this because from this point the two light rays are emerging. So this is a real object, right? And we have these 2 points, right? But the light rays are going from here and here, right? So we will draw these line backwards, and it will appear that the line is emerging from this point. So from this point, it is appearing that these two light rays are emitting or emerging from, right? So what kind of object is this? The light rays are emerging from here, right? And when we extend these two lines, so then we'll get this point. So from this point, it is appearing that these two light rays are going out, right? Or diverging from. So then what kind of object is this?
Virtual.
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 So this is the virtual object. Okay. And then we have this image. So image is also of two types. One is this real image, and the other one is this virtual image. So whenever two light rays are converging or meeting at a point, then that would be called an object, image, right? And whenever two light rays are appearing to be converging, then that would be called a virtual image. Clear?
Yes.
Okay, so we have, let's say we have this point, right? So two objects are meeting at this point, right? Then this is a real image, right? And let's say we have these 2 points, right? And these two rays are incoming, and let's say at this point. So at this point, right? So this would be called what? So this is a virtual image, right? At this point, these two rays are appearing to be meeting. So is that clear? We understood that what is the light, and then we understood about the aspects of light, that there would be some object, and that we also call that we can also call the source, right? And then there will be this image. So where we are observing that object, right? So there would be object and there would be image, and the object would be of two types. One would be real object, and the other one would be the virtual object. And then there would be this image, so real image and virtual. Is that clear, guys?
Yes, sir.
Sir,
Yes, yes. Oh, so did you say? Do you have any question?
no,
Okay, so please note down from here, guys. Right. So please. uh, And there would be some things which would be repeating whatever you have learned in your 10th class. So some portion would be of those 10th class. So yeah, for few classes, some things would be. So we have to just revise this. Whenever you guys want me to scroll down the screen, guys, please tell. Whenever you guys want me to scroll down, please tell. Yes, noted everyone.
Yes, sir.
Yes.
Okay, so then please. Not repeating but emerging skills. Right? Repeating would be a difference.
Sir, can you scroll a bit up? I missed some part.
Which part?
Yes, sir. Yes, sir. Just the light propagates in rectilinear motion.
Oh yeah, this part.
Yes, sir.
Yeah, all these things were just to tell you that why light propagates in linear motion, right?
Hmm.
Because light is an electromagnetic wave. Why it is not moving like electromagnetic wave? It is moving, but our naked eyes cannot comprehend that it is moving like a wave, right?
Yes, sir.
Okay, so did you note down that part?
Yes, sir.
Then please. So whenever you guys have noted it down. There is some correction in here, right? This would be like so this is the virtual object, right? This is a virtual object, and this would be the in here. Whenever we are extending, that would be the virtual one, right? So these are meeting at this point. So this is the virtual, right? Yes, please correct that, and yeah. So should I scroll down this screen, guys? Whenever you guys have noted it down, please tell. Noted, everyone.
Yes, sir, I'm done.
Yes, Aisha, me, and Maya. What about you guys?
Done, sir.
Okay. So the first property of the light that we'll talk about is reflection of light, right? So whenever light bounce back from a surface, right? So there are two laws of reflection. So let's say we have this plane, and some, let's say, light is incident on this plane. So this would be called the incident ray, right? And then when we draw a perpendicular to this plane, so that would be called the normal ray. And then we have this, so then the light will bounce back from this surface, right? So this would be called the reflected ray. So there are two laws which govern the reflection of light, right? So there are two laws of reflection. The first one says that the angle of incidence, the angle of incidence would be equal to the angle of reflection. So we always measure the angle with this normal ray, right? So this would be the angle of incidence, and this would be the angle of reflection. So angle I would be equal to angle. So this is the first law of reflection. And then the second law is that the point of contact of incident ray, normal ray, and reflected ray will lie on the same plane, right? So there is this plane, right? This is the plane where this reflection is happening. So the point of contact of this incident ray, this normal ray, and then this reflected ray. So this would be on the same plane, not like the incident ray would be in here. So this would be the point of incident ray, and this would be the point of reflected ray. So this is in this plane, and this is in some another plane, right? So those 2 points would be not lying on the different planes. All those points would be at the same plane, right? So these are the two laws of reflection which governs the process of reflection, right? Is that clear? So this part you have already done, right? Okay, and there is this sign convention also. So the plane mirror is not in the syllabus, right? That we have studied in our 10th class. Spherical mirrors we have also studied, but let us recap that. So we have this spherical mirror, right? And when we measure, so let's say this is the pole, right? Where this principal axis, this is called the principal axis. And whatever point this principal axis cuts this mirror, so that is called the pole, right? So whenever we measure the distances above this principal line, so that we take as positive. Whenever we measure the distances below this principal line, so that is negative. Whenever we measure the distances to the left of this pole, so that is negative, and whenever we measure the distances to the right of the pole, so that is positive. So this is the sign convention, right? All of you guys, right?
Yes, sir.
Okay. And then there are two kinds of spherical mirrors. So this is a concave one, and there is this convex mirror also, right? This is the other. And for this mirror, there are different important terms. So one is this focus of this. So focus of the right? Spherical. So this is defined as the point where all these incoming light from the infinity are meeting at a certain point. So the line coming parallelly to this principal axis, and whatever point they are meeting, so that is called the focus of this, right? So this is going in this way, this is going in this way. So there, this is the image that is forming, right? So light is coming at this point. So this point is called the focus of the mirror, right? And for the convex mirror, so the lights are reflecting, so they will be appearing to be meeting, right? So let's say this is these are the lights. So they will come in this way, and then they will reflect. So they will reflect at this point, right? So you guys can see that what kind of image would be this. Here these
Virtual.
virtual, right? So this would be virtual. So this is called the focus of the image, where the lines are meeting or appearing to be meeting, right? So these are the focus of the mirror, and then there is this curvature of the mirror, which is the center of the curvature of this whatever the spherical mirror is part of. So that the center of that sphere is called the curvature of the sphere, right? So this is called the curvature. This is called the focus, right? And then we have these image formation laws. So these are all the things that you have already learned in your 10th class. I'm just recapping. So first one is that the definition of the focus that we have. So all the lines parallelly coming to the principal axis, they will cut through the focus. So this is the first image formation law, right? And that is the definition of the focus also, right? And the second law is that all the lines that goes past this focus, so then they will reflect parallelly to this principal axis, right? So let's say one line is coming in this way, so this will go parallelly to the principal axis, right? This is the second thing. And the third thing, so these are focus, right? And then we have this third image formation, which says that so at whatever angle they are coming, right? And this is the normal ray, right? So the laws of reflection it will follow. So this is whole, right? And this is coming at this angle. So this will reflect with the same angle. That is what laws of reflection says, right? So this is angle of incidence. This is angle of reflection. So the whatever angle is it making with this pole, then it will reflect back with the same angle. So this is the third law. And fourth image formation law is that, so if, let's say this is the center of curvature, this is the focus. So if it is coming at the passing through the center of curvature, so it will reflect back with the same path. These are the four laws of image formation, right? So these you already, right? Is that clear, everyone?
Yes, sir.
Okay, so now there are two things we have to prove using all these, right? So one is that one thing that we have to prove that the center of curvature, so from the center of curvature and at this pole, so this is the radius, right? And then we have this focal length here. So one thing that we have to prove is that this radius is twice of this focal length. This is we have to prove. And the second thing that we have to prove is that the second thing that we have to prove is that one, so mirror formula that we have. So these are the two things that we have, right? Using all these image formation and using the laws of reflection. Okay. So let us find about this relation and this relation. So first one, let us prove this one, right? So uh, we have this mirror, right? And I'm only using this concave mirror, so but we can do this with the convex mirror as well, right? So we have this focus, and then we have this center of right. So let's say some light is coming with this angle, and let's say this is right. So this is theta, or let's say this is 2 theta. So this would be 2 theta, right? And let's say this is the angle with which this is. So this is 2 theta. So this would be half half, right? Because this will pass and this will come back. So this is theta, and then this is theta, right? So for center of curvature, this would be the same angle, and for focus, this would be 2 theta. Is that clear, guys?
Yes, sir.
Okay, so now this is the distance r, and this is the distance which is f. Okay, and these are very small angles. So let's say this is some distance a, and let's say this is a, and this is okay. So for let's say this triangle, for this triangle, triangle ABC, right? And let's say this is so in triangle ABC, what would be tan theta? How much would be that? Remember, tan theta is perpendicular by base, right? So what is perpendicular? Yes, guys.
Mhm.
Perpendicular is AB, right? And then we have this base which is BC, right? And this is very closer to, let's say, P. So I can write BC which is nearly equal to C, right? This is nearly equal to K. And what would be in triangle, let's say, in triangle ABF? What would be tan 2 theta? What would be tan 2 theta? Yes, guys, what would be tan 2 theta? Perpendicular, so this is the triangle that I am taking, right? Perpendicular by base. So AB by this here, right? And this BF is very closer to this, so BP is very small. So this BF would be equal to F. Okay, is this clear?
Yes, sir.
Yeah, and for a very small angle, so for very small angle, your tan theta is nearly theta. So similarly, tan 2 theta would be similar to 2 theta. So if we put back that value, so theta would be AB by, let's say, CB, right? And your 2 theta would be AB by this FB. Okay. So let's say this is 1 and this, let's say this is 2. So if we calculate AB from here, so AB would be theta into CB. And from second, so this is from first. And from second, AB would be 2 theta into F. Okay. So we can put the values of AB, or we can compare these two relations. So which means that theta into CP, this would be equal to 2 theta into F. Right. So theta cancels, and CP is how much, guys? CP is how much? Distance from pole and center of curvature. So what is that? Let's say this is the circle that you have, this is the center, and this is the pole. So what would be this?
The radius.
Radius, right? So this is radius. This is radius, and we are calculating FP. So from focus to the pole, that is focal length, right? This would be 2F. So this was the first. Any doubt in this part, guys? Any question? Yes, guys, any question?
No, sir.
Okay, so please, these are just the revision of the 10th class that you have studied, right? So you guys, please note down. This part you have already studied, but just for the cap, right? So in whose class this chapter or the second book has started? So in your school, me, did they do this reflection portion in your school?
Yeah, sir.
And what about you, Aisha, Mariam, and Arshada? Did they start? Did they
Yes,
do?
sir.
Okay, they have started. So this was just the recap that we already did in our 10th class, right? So that's why I just fast forwardedly did this part. We will focus more on the reflection part. So that part is new. You guys already did this refraction part, but without the reflective. But now we will see the use of this. Okay, whenever you guys have noted it down, please Yeah, noted everyone.
Yes, sir.
Yeah, please note down this. So just draw the images because the wordings look right. Yes.
Yes, sir. Can you go a bit up? I just need to finish the sign convention.
Oh, this is the convex mirror, right? And this is the convex. So same sign convention for the convex. That is why I'm not right.
Yes, sir. Scroll down.
Yeah, noted everyone. These four laws are very important. Please, right, and these. So in the optics or ray optics, these arrows are very important. So this will show that the rays are incoming, and this will show that the rays are outgoing. So the rays are incoming and rays are outgoing. So these are very important, right? So this is saying that this is outgoing and this is incoming. This is incoming and this is outgoing. Okay. So then please Yes, guys, whenever you want me to scroll down the screen, you guys, noted up to this point.
Yes, sir.
Yes, everyone noted? Aisha,
Yes, sir, I'm
Manu,
done.
Arjuna, Steve. Yes, guys, what about you guys? Done?
Yes, sir.
Okay, so now we have some image, right? We have some object, and there's this. So there is this object distance, right? Which is u, and then there's this image distance, which is v, and then we have this focal length, f. So we have to find out what is this mirror equation or mirror formula. The mirror formula relates all these three points, right? So let us draw these things. So first is let's say this is focus, and this is center of curvature, right? And we have an object which is at this place, right? So the light rays are coming from this object, and they will pass through this. So this is the first image formation law, and then we have the second one, so which says that light going through this focus, right? That will pass parallelly to this. So the light going through the focus pass to this parallelly to this principal axis, right? This is okay, and the third one is this one. So why do I need this third one? So you guys, the third one is the angles are not being equal, but yeah. So this one is this one. So these are this is the point where all the incoming lights are converging, right? So this is the image. Okay, this is A, B, and let's say that this is the image A dash. So first, what we will do is that we have to prove that 1 by V plus 1 by Q equal to 1 by F. So this is the first thing that we have. So the idea is that we take two triangles, right? We take two combination of triangles. we take two combination of triangles, and then the second is that we use property of similar triangle. Right, and third one is, which is very important, is that sign convention. So all these three things, right. First is finding out the triangle. So in first case, we will take these are two triangles. This one and this. So the first triangle is in triangle A, B, and P, and triangle A dash, B dash, and so these are the two triangles that we have. And this is theta and this is theta, right? Because the angle of incidence, that would be equal to the angle of reflection. So using the laws of reflection. Okay. So these angles are equal and these angles are 90, right? So angle A is equal to angle A prime, each 90 degrees. And then this angle BPA, that is equal to angle what? So B prime BA prime. Using the law of reflection. So then these two triangles are similar, right? Then triangle APP similar to triangle A prime B prime P prime. Right, guys? Is that clear?
Yes, sir.
So properties of a similar triangle says that the corresponding sides would be proportional, right? Whenever we have two triangles which are similar, then their corresponding parts would be proportional. So let me write that AB by AB A prime B prime. That would be how much? Let us use this one. So AP divided by this A prime. Is that clear?
Yes, sir.
And what is AP? What is AP? This is the distance from the pole to the object, right? So that is object distance, U. And what should be the sign that we should use? Because we are moving in the left direction. So what should be the sign? That is minus U divided by, and then we have this one, A prime B. So this is where this image is formed, right? So A prime B is minus. Here is this clear, everyone?
Yes, sir.
So this is the first relation that. Okay. What the time is over, but we can. Yeah. So now we can take the second triangle. So let us take these two triangles. So this one and this one. Let's say this is okay. So this one and in triangle. in triangle, what do we have? Triangle. This is the triangle, right? Right. So what about these angles? What can we say about these two angles? Yes, guys.
So they're equal.
There you go. Because they vertically opposite angle, right? So
Yes,
they
sir.
are. Let's say this is M, and these angles are equal. This point is what? That is. So in triangle A, B, F, and triangle M, N, and these are the two triangles. We have, let's say this is 1 and angle 2. So angle 1 equal to angle 2, vertically opposite angle. And then we have this right angle. So angle A equal to angle, right? Each 90. So again, these two triangles, triangle A, B, F, is similar to triangle M and F, right? And correspondingly, this is due to AA criteria. And correspondingly, AB by AF, that would be equal to MN by ML, right? So we can write what is this AF? What is this AF, guys? So whole distance is U, and this distance is F, right? I'm calculating this distance. So how much would be that? AB by AF. Why is there I by AF? AB by F. That is equal to MF AF by this, right? And you guys can also see that what is this MN? When we compare this MN with this A prime, B prime, so what would be that? Yes, guys. Okay, so already the time is extended. So I will stop it here. In the next class, I will start from here. Okay. Because you guys can see that this A prime and B prime, this is equal to this MN, right? Both are parallel, so this would be equal, right, guys?
Yes, sir.
So then these left hand side would be equal, and then we have to prove the, yeah. So I will stop it here, and I will again start this one. So yeah, in the next class I will do the second, right? So no